All right, guys, welcome to Unit 2. This will be the first part of Unit 2. This is about 47 slides. I know, it's a lot of slides. So I'm going to break up the first lecture into two parts. I will cover about 23 slides here, and then the next part will cover the remaining slides. So, pause when you need to read, or whatever I explain here doesn't make too much sense. Again, reach out. We can talk about it. I could probably make a class discussion so we can get more input from people and it'd be more fun. And on the third recording, which will be for the second half of this unit, I talk more about virtualization. So I'm going to talk about different boxes. We're probably going to install another virtual machine kind. We're not going to be using well, we are, but we're not going to be using just one kind of virtual machine the whole time. We'll do some other stuff. Don't worry. When we get there, we'll get there later today, which is when you're looking at this lab will probably be, or this unit, which will probably be Sunday. It's Thursday for me, so I plan to have everything done hopefully by Saturday. So by Sunday we can be, you guys can be ready to rock and roll, and then we go from there. So, all right, without further ado, here's what we're covering in this part of Unit 2, the first part, outline for Unit 2. So you can see what we're covering, right? We'll talk about routers, switches, access points, firewalls, and security applications. VLANs and routing. That one's, I'll be honest with you, that one's a little hairy. It's going to be kind of boring and dry. So just, hold on, pay as much attention as you can, and pause it as much as you need to, get a grasp on it. Take notes. It would help you out. So also sometimes if you're looking at these slides without, watching the video, I leave notes on the bottom too that hopefully help out. That's one or two notes here and there sometimes. And the last thing I cover for this unit or this part of the unit is network security best practices. So let's get started with routers, switches, and access points. So routers, switches, and access points, all three, operate at the network layer. You'll remember I had you guys look at OSI models, talked about in the networking, operates on the network layer. Connects LANs, which are local area networks, and WANs, wide area networks. So, WAN, you can think of, honestly, schools, like your public schools are your best examples of WANs, because, you can have an elementary, then a mile away, you have a middle school, then another mile away, you have a high school, and they're all connected on the same network. That's a WAN. You also have another one that's called a MAN that I didn't mention. And well, MAN, is that a person? No, it means metropolitan area network. And that's more for like the big city. Let's say Sacramento, for example. Every government building in Sacramento, be it a police station, local government, fire station, what else is local government? A hospital, technically, to some extent, county offices, city hall, like all of those would be networked together, and that would be under a MAN, not a WAN. It's different in that aspect because it covers the whole metropolitan area. Well, schools might span the whole area, but they don't really fall under the MAN because they're more niched in terms of what their use is versus a MAN, which is built more for city infrastructure. I hope I'm making sense of what I'm saying. So moving on from there. So connected LANs and WANs, I mentioned, with similar or different protocols together. Okay, then from there it goes switches and bridges, isolate connection, collision domains. Well, what does that mean? So switches and bridges they do. Essentially, look at everything that might collide. You say, hold on, man, wait for this packet to move, wait for that packet to move. I have a picture of a packet later down the line. But forward broadcast messages to all LANs connected to them. So they send out signals to everybody saying, hey, we're looking for this, we're looking for this. Then it'll respond that I'm over here, then it sends information that way. Routers isolate both collision domains and broadcast domains. Yeah. Acts like normal stations on the network, but have more than one network address, an address to each connected network. That's when we get more into VLAN. That should clarify that a little. Deals with global address, network layer address, IP, not local MAC addresses. So yes, those look like the grand scheme of IPs on the network, which can range from like, I don't know, zero is usually reserved, if I remember right, for your telecom, and one is your gateway. Then after that, from 2 to 224, that's the last digits of the IP. It's called an octet, by the way. Let me pull up mine, so I'll show you what I'm talking about. I know I'm trailing off about it, but it's just so you guys can kind of see what I'm talking about. Let's talk about addresses. Let's go right here. So see how mine's preferred 9? I have mine set to what's called static, so it doesn't change. So my computer is always .9 at the end of it. So that's my internal network, and that's what the LAN would deal with. It would deal from everything from 2 all the way to 224 if I had 224 devices. So that's what that's referring to when it's talking about that here. And it's not looking at the Mac, which was up there on the screen as well. It doesn't look at Mac. I'm sorry, over here. Macs. It's looking at just those strictly APs. Right? Communicate with each other and exchange routing information. Yeah, they talk to you like, hey, where's this? Hey, where's that? Okay, send it here, send it there. It's kind of like a post office, kind of like a zip code. Same thing. You know, part of the city is a different zip code. Houses fall under that. Yada yada yada. Determine best route using routing algorithm by special software installed on them. Yeah, so that's trying to remember the name of it. There's a specific name for it. It's not pathing. I'll need to remember. We'll talk about this more later though, but you can have it set it up, or you can do it. Oh, dang, it's all spanning trees. I remember the name. Sorry guys, it's escaping me this one because I haven't done that in a while. But anyhow, you usually program it yourself because it has to count the hops, and normally when it does it on itself with the software, the hops are just too long. And if it takes, let's say it costs 8 hops, right? And I don't mean like totally like all of those jumps added together make 8, versus these 3 hops altogether added make 13. It'll do 13 because it's shorter, but in reality 8 is shorter. It's just something that you cover in networking more. I think I mentioned it. If not, let me know. We can talk about it more later. So it forwards traffic if information on the destination is available. Otherwise, it discards it. Not a switch or bridge. Yeah, that's pretty much what it does. Just forwards info. So moving on. This is how routers work. So as packets are passed from routers to routers, data link layer source and destination addresses are stripped off and then recreated. I should have put the packet in here so you could have seen it. I'm sorry, the packet's in further down the line when I talk about switches, but it applies to this a little bit too. So it enables a router to route a packet, see, part my packets in, from TCP/IP Ethernet network to a TCP/IP token ring network. That's a different kind of network. You can look it up if you're curious about it. I think I have a picture of that next. Only packets with no network addresses will be passed, hence reduce traffic. So, hey, where you going? It's like stop and tell. Where you going? And tells it, oh, I'm looking for computer B. Oh, computer B is that way, so it's computer B. Routers can listen to a network and identify its busiest part. We'll select the most cost-effective path. Let's talk about pathing for transmitting packets. Oops, meant to go forward and go backwards, guys. Sorry about that. And we are on slide 5. So, routing table. What is a routing table? It's underlined because it's important. A routing table is a set of rules often viewed in table format. Pretty straightforward, right? That's used to determine whether data packets travel over an internet protocol IP network will be directed. Makes sense. This table is usually stored inside the random access memory of forwarding devices, such as routers and network switches. Routing table is formed, that's what I was trying to remember what it's called, based on communication between routers using routing protocols. And this is in red and underlined so you guys can know that they're not the same in the definitions under there. Routing protocols are not the same as routable protocols. I guess I left the definition next to it, but yeah, I'll erase it later. So when you guys get it, that won't be there. Just anything after the protocol part. But the definition of a routing protocol is a set of predefined rules, which is talked about there, used by the router to maintain the communication between the source and destination. Okay, well, how's that different from a routable protocol? It allows packets to be forwarded from one network to another. So the routable protocol works on the network side, where it goes, hey, it has to go that side of the network, it has to go that side of the network. The routing protocol works to maintain communication between sources and destinations in the routing table. Okay, so don't they're not the same. That's more for networking though, but it's pretty important to know. Hint, nudge. There might be a question about that on the midterm. You didn't hear that from me. Routing protocol collects data about current network status and contributes to selecting the best path. The best path. Same difference, right? So here's what that kind of looks like. Routers connecting independent LANs. So these are all different LANs, right? And this is a router. This is a wide area network, WAN. Connects to this router and connects to that LAN, connects to the rest of the internet. See? So it helps you span. This is just an example of what it looks like. So hopefully it's not too confusing, but I feel like pictures usually help. So let's talk about some advantages and disadvantages of routers. So, as I just mentioned, advantages and disadvantages. So some advantages. Routers provide specific routing, flow control, and traffic isolation. Routers are configurable, which allow network managers to make policy based on routing decisions. So you can, who would take priority, like BBP, CEO, you can give them, a higher, shorter router path. So they can, it's 2 hops, so they can nearly instant transmissions. Routers allow active loops so that the redundant paths are available. Yeah. Some disadvantages. Router are protocol-dependent devices that must understand the protocol they are forwarding. So they essentially have to know the language of the protocol, the language in the sense of they have to know how their table looks like and works unless it's been changed. Routers can require a considerable amount of initial configuration, Wires are relatively complex devices and generally are more expensive than bridges. Bridges are pretty cheap, but I don't really talk about bridges much. Bridges are kind of an old school way of doing things. Now, if you're curious, I'm segueing out of this for a second, and you want to look at the first kind of network tap, you want a network or a network port, what we used to call a vampire tap. Look it up. Vampire taps are pretty cool. That was the first kind of networking that people would do when the networking started becoming popular around mid 80s, started taking off, and the coax cable at the time was the most popular thing. Coax is like a strip of cable and you thread it in. And well, we need to add a port to this. Well, nowadays, right, you can have like a network port in the wall. It's like Ethernet jack, you plug in and you're good to go. These literally are called vampire teeth or vampire taps because they would drill into it and tap the wire. They're pretty cool. Look them up if you're curious. Just a little tidbit of information I throw out there. So let's talk about switches. So what's a network switch? I'm sure some of you have seen a switch. That's kind of what it looks like. They're usually referred to as dumb switches. Well, what do you mean? Well, they're dumb. You can't really program. They just work. They're just there. You know, they're like, all right, they already have their baked-in programming. They just know how to move things and provide ports, and that's all they do. Also, there's another thing you could do with these. You can multiply the ports easier too. Well, what do I mean by that? You would take one of these ports here. Move my mouse over. Like one of these here on the bottom, or this doesn't matter. As long as there's these first and these up here, these are reserved for these right here at the very end. Or I know it's hard to see, but those are for fiber optic inputs. So you can talk to an ISP for that and do all that stuff to route network around. But these guys, you can daisy chain. Well, what's daisy chain mean? You take a network port here, like one of these guys, not these guys. Plug it in here, plug it into another switch like this one under it in any of the ports other than the ones I've said earlier. And then you can have more ports on the same network. So anyway, so what's a network switch? A network switch is a hardware component responsible for relaying data from networks to the destination endpoint through packet switching, MAC address navigation, and multi-port bridge system. So see, this one does use the MAC addresses, but routers do not. Switches operate at the data link layer level, layer 2 of the OSI model. The network switch connects and transmits data packets to and from devices on a local area network, LAN, right? By having multi-port can be used limited bandwidth. Yeah, pretty much straightforward. Far from a router, a switch only distributes information to one device for which it was designed, including some other switch, a router or a user's computer rather than to several devices in the network. So it goes one way, so it goes to one computer only specifically, go next one, it kind of makes a line of things it has to send things to. Moving on. So this is what a switch looks like on a network, right? So this is the connection speed between here and the hub, network hub. 10 megabytes, but these plugged in directly are 10 megabytes. You can see what that looks like. Switches divide a network into several isolated channels. If it's a 7-port switch, 32-port switch, etc. Packets sent from one channel will not go to another if not specified. Should change that. Each channel has its own capacity and need not be shared with other channels. Forwards only to the port that connects to the destination device, known MAC address. Match the MAC address and the data it receives. Now I'm going to talk about that packet I talked about earlier. So this is another method that you can do. It's called switch routing, right? Packet-based switches use one of the following methods to route packets. There's two, from what I recall. Cut through reads the first 14 bytes of each packet and transmits. So it's going to read this. If that should be 14 unless it's 2, depending on the size. That's why it's saying 2. So I can read up to here or read up to here, depending on the size of these here, destination source and source address. So it's much faster, cannot detect corrupt packets, though, which means it might have some issues and might cause some congestion on the network and get slowed down. You have what's called collisions, smacking each other. You can propagate the corrupt packets to the network, which means you can just send them. Best suited to small work groups. So this is something you would see like in a small internal network, what's called an intranet. Intra, right? Makes sense. That's like a small network that doesn't need to have internet connections. Like for example, sometimes I do work at the local jail for our department when we have classes in there, which we do. We have a program for the jail. We have an intranet there, which is about 20 machines big on a 40-port switch. And we use cut through because it's not going anywhere. It's not going to talk to the outside. So it's making my life a little harder, but that's for updates and stuff. And, don't need to worry about that. But it's a jail, not supposed to have the internet. Anyway, my point is that this is still used in the industry. So you'll see it sometimes. The other way it routes is called store and forward mode. Reads the whole packet. So if I go back, reads the whole packet, reads this whole guy right here, right? So it reads that. Slower than cut through, though. More accurate since corrupt packets can be detected using FCS. I might make that extra credit. I'll think about it. More more suited to larger LAN since they do not propagate air packets. It's this data transfer between segments at different speeds. So it can check for corruption and not send it, and I request a new packet to be sent that's clean. That's what that means for this right here. So moving on. Yes, I use Morph a lot. I'm sorry if that like hurts your eyes. I didn't mean to. And man, it just looks clean. I'm sorry. Advantages of switches. Switches divide a network into several isolated channels or collision domains. Reduces the possibility of collision. Collisions only occur when two devices try to get access to one channel. Can be solved by buffering one of them for later access. Buffering means you kind of put it into a pause pattern and wait, like, hey, hold on, let me finish this and I'll do this. Then it goes on to it. You know, buffering, like when you're on YouTube, for example, and so it just it loads, stops, and then buffers or loads more because you're waiting on a switch to get some information from YouTube. So now you know. Each channel has its own network capacity, suitable for real-time applications, video conferencing, example. Since isolated, hence secure, which is cool. It's security is kind of baked in already at that point for these. If they're on an intranet, I wouldn't argue if they're out there in the wild, you know, on a public network, that's a different animal. Data will only go to the station, but not others. Pretty straightforward for switches. Switches, like I said, they're called dumb. But here's some downsides or disadvantages of switches. Although it contains buffers to accommodate bursts of traffic, can become overwhelmed by heavy traffic. Device cannot detect collisions when buffer full. It's like a holding area. So if you have a holding area for the packet, which I showed back, and you're just full of packets, and you can't stuff anymore, it's like trying to put things into a drawer. It's just stick it out. You're just trying to cram more stuff. Can you close that drawer? Yes or no? Probably not, because that drawer is stuffed or overflowing. It might break on you or burst out, and you know stuff might hit you in the face. So ESMA CD scheme will not work since the data channels are isolated. Not the case as in Ethernet. Some higher level protocols do not detect error. UDP does not detect error. Those data packets are continuously pumped to the switch and introduce more problems. So it can just back up and just get huge, just like being stuck in rush hour traffic where you can't move essentially with network information. Like it would be down to a trickle. So let's talk about access points. Moving on. What is a wireless access point? You may have seen these in buildings, just white squares hanging up there with blink lights. Wireless access point is a network device that allows wireless capable devices, to connect to a wired network. Okay, it's pretty straightforward. So, you know, let's connect a wireless device to a network. Okay. It is simpler and easier to install wireless access points, WAPs, WAP, to connect all computers or devices in your network than to use wires and cables. Yeah, that's true, but here's the thing. Wired will always be faster than wireless, no matter how you look at it. And we're 14 slides in, by the way. So 11 more, take a break, and then I'll record the second part. So why would you use, you know, WAP to set up a wireless network? Using WAP lets you create a wireless network within your existing wired network so you can accommodate wireless devices. And it's kind of stating talking twice. You can also use wireless AP or mesh extenders to extend the signal range and signal strength of your wireless network to provide complete wireless coverage and get rid of the dead spot, especially in larger office spaces or buildings. Additionally, you can configure the settings of your WAP using a single device. So I'm trying to think. I don't know if you guys have seen it. You go to the store and the mesh right now is a new hot thing in home networking. So essentially what mesh is what I have at home. I'll be honest, I upgraded. I used to have a regular big old router, which is great, but signal kind of sucked. Mesh essentially is, it still acts like your previous wireless router, but you have something called a satellite, which you would, you know, put at the corner of the house where you can't get that much signal. And what it does is it changes between radio bands constantly to give you the strongest signal possible, so you can connect whoever's around there and you won't degrade your signal and lose signal. And that's essentially how mesh kind of works. So hopefully you learned something from that. So let's show you some access point configurations. This back here is an access point. I'm sorry I couldn't fit the picture in here because all this text, but it is what it is. So roof access point I mentioned, or root, sorry, not roof. In this configuration, an access point is connected directly to a wired LAN, wireless local area network, providing a connection point for wireless users. If more than one access point is connected to the LAN, users can roam from one area of a facility to another without losing their network connection. This one right here, I would argue, whoops, didn't mean to go forward, is the one you see the most, I think, in government, in hospitals. If you look up, you'll see them all over buildings now. Like I'm trying to think where my office is where I work, and I have like 4 on the bottom floor alone, or 5. 1, 2, 3, 4, 5, 6, including a stairwell. And they're just acting as root access points. They don't act as repeaters, which I'm getting into right now. So a repeater access point, RAP, same thing as root, right? RAP, An access point or mesh extender can be configured as a standalone repeater to extend the range of your infrastructure or overcome an obstacle that blocks radio communications. The repeater forwards traffic between wireless users and the wired network by sending data to either another repeater or an access point that is connected to the wired network. The data is sent through the route that provides the best performance for the client. So I'm talking about the wireless signal. So a repeater also, the problem with this kind of it came up originally in radio, where they would send signals from towers, right? So a signal will go across the land, and it gets fuzzy. Trying to tune your favorite radio, so you can't hear it; just fuzzy, cuts in and out. You would add another station, another antenna somewhere in the middle to boost it, and that's what was called a repeater. So it goes through something. The signal for the wireless radio would go through something that's called attenuation. Attenuation is just a fancy way of saying it's losing strength. So the repeater acts as a booster essentially. So it could pick up the network, from my laptop, my phone, whatever I'm staying, and just sends that signal back to an access point to the network that's closest that hopefully would see it, which should see it if it's configured properly. And it will boost the signal back and forth between them. So again, it acts as middleman, it acts as a repeating station, repeater. That's how it gets the name. So bridges, which I forgot to put in some points. I'll fix that hopefully today. Access point can be configured as a root or non-root bridge to join multiple networks. An access point in the role will establish a wireless link with a non-root bridge. Traffic is then passed over the wireless link to the wireless network. A bridge helps you get over. Workgroup bridge. An access points that are in a workgroup bridge can associate to other access points as clients and provide network connection for devices connected to Ethernet ports. So kind of works a little backwards here. Yep, now we have yeah, so you can essentially hook up stuff to this and then have it set to workgroup bridge mode, and those get network connection. So it's just taking signal and pulling it this way essentially. Central unit in an all wireless access network is in an all wireless network. An access point acts as a standalone root unit. It is not attached to a wired LAN. Instead, the access point functions as a hub that links all stations together. It serves as a local point for communication range of wireless users. Yeah, but it's not connected to a LAN. It's not really doing much. It's just internet work and stuff. So you don't see that one that often anymore. Only in internet situations where they want to be wireless, you would see that bottom one. So let's move on to slide 15. Advantages of wireless access points. More user access. An ordinary wireless router will only support 10 to 20 users accessing it. I should fix that. While AP is able to allow over 50 or even hundreds of users access. And what's more, it has stronger ability to send and receive signals, which is great. That's what they're built. They're built for this kind of stuff. They're built to take the punishment of having multiple users on. So broader range of transmission. Generally, the range of signal transmission that a wireless router can cover is just dozens of meters. Yeah, if you had a wireless router in your house before and you haven't had a mesh network or an AP, which you can add at home, but isn't recommended because it's more of an industrial thing in the sense of you don't see it at home, and it's beyond the range, signal will be lost. That happens. Signal cuts out, right? If you have just a one wireless router for like a 2,000 square foot house, imagine. Yeah, it's not going to be able to cover everything. Nevertheless, an AP can cover fluid distances up to 100 or 300 meters. That's pretty good amount of range. And the increase in wireless access points will extend signal coverage proportionally, which enables users to roam freely in the network. So you can be from one end of the building to another. Flexible network. The networking mode, the wireless router is relatively single with low flexibility. On the contrary, an AP has a variety of modes for you to choose, which means to be very flexible, such as simplex AP, wireless client, wireless bridge, multi-point bridge, etc. There's a bunch of other ones. I'm not going to get too far into it, guys. It's just an overview of how they work and what they do. I don't want to, throw you into the deep end of this stuff. We're not going to get that far because this isn't a networking class. You just have to know how these things work too, because you'll see them. If you take networking, I'm sure there's stuff they'll cover. I hope. Well, actually, if you take like a build your own home network course, they would cover this more than I am. Multi-AP interconnection. The enterprise can design the wireless program flexibility according to its actual situation. Multi-AP interconnections can give full play to its advantages. Multi-AP applications are typically found in businesses but rarely exposed at home. So let's talk about some disadvantages. Disadvantages of wireless access points. High cost. Not typical for home use. I did mention that earlier. More for enterprises. When the scale of enterprise wireless network is large, the more wireless APs are needed. Thus, the higher cost that enterprises want to take broader range of transmission. Typically costs between $300 and $500 a box. They're not cheap. Maybe $200 nowadays, but they're still. Do you want to spend $200 on just an access point when you could spend 180 like on a Netgear orb system. Excuse me. That comes with one new router and one satellite, which you can put anywhere. It works better for the home. Inability to use alone. APs can't be used alone. Can be directly connected to ADSL, asymmetrical digital subscriber line, digital subscriber loop line modem, and just a DSL modem. And it needs to be used in conjunction with other equipment like switches, controllers, Ethernet hubs. So you need to have, if you were to use these at home, you need to have a switch. Okay, and you have a controlling hub, then an Ethernet hub, then a server. Like, do you want to go through all that just to get internet at home and make it super strong so you can reach to the end of the block? I don't think so. Sounds expensive too. Like, not up my alley, guys. So let's talk about firewalls and security appliances. So what's a firewall? So if I go to Windows Defender, this is a firewall. It's a software firewall, but still a firewall. I'm not saying it's great, but sorry, let me pull it up again. Yeah, this is a firewall, so cool. Let's say on my home network. I guarantee you can't do anything with it. Anyways, so okay, so that's the kind of firewall. So what is a firewall? A firewall is a network security device. Normally they're physical devices or software devices now, that monitors incoming and outgoing network traffic and decides whether to allow or block specific traffic based on defined set of security rules. So even this Windows one, if I pull up, I know it's not the best firewall, guys. I get it. Trust me. Let's go to allow through here. I'm deviating for a second. You see? This allows stuff. You can see all my stuff. It's fine. I'm not hiding anything. But that's allowing and denying. You can do stuff like that. You can even set custom rules and stuff. I'm not going to have you do that on your personal computer. Maybe on the virtual ones. I'll think about it. Firewalls, and I talked about that, right? Firewalls have been a first line of defense and network security for over 25 years. So they go back to about, 25 years ago. It's like what, 1998 off the top of my head. So, or 7, around there. That's not the truth. That quote's wrong. I need to probably update that. They've been around since, God, since like Windows 3.3, roughly. Right when the internet took off, like literally like 3-4 years later is when it happened. If you want to know about the history of the internet, I can talk about that later. It's not for this. They established a barrier between secure and controlled internal networks that can be trusted and untrusted outside networks, such as the internet. A firewall can be hardware, which I said earlier, software, and the new ones are software as a service. You're going to see that probably for the rest of our lives now. Public cloud or private cloud. So the software very evolved into the software as a service, which evolved into public cloud, which evolved into private cloud firewalls. I'm not going to really talk about those that much because they get really dicey, but they're mentioned in this in passing. So here are the different types of firewalls that you can get more details on here. So we have a proxy firewall, an early type of firewall device. A proxy firewall serves as the gateway from one network to another for a specific application. Proxy servers, so you've probably heard of that before. Hopefully, if not, we can talk about it later. Can provide additional functionality such as content caching and security by preventing direct connections from outside the network. However, this also may impact throughput capabilities and the applications that they can support. Stateful inspection firewalls, not thought of as traditional firewalls. So proxy was the first one that was big in like the late early 90s to like late 90s, early 2000s, and stateful inspection came out somewhere in the middle tail end of the 90s and took over. So that's why it's saying it's now thought of as traditional. Now thought of as a traditional firewall, a stateful inspection firewall allows or blocks traffic based on state. So where's it coming from? Port. Which port is it coming through? Is it coming through port 43, port 44, port 23, port 21, port 22, blah, 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 blah. It monitors all activity from the opening of the connection until it's closed. So it says, okay, port 20 is requesting this. Let me check it out while it goes in. And it checks what it does the whole time while it's connected until it disconnects. That's how it works. Filtering decisions are made based on both administrator-defined rules as well as context, which refers to using information from previous connections and packets belonging to the same connection. So if it sees someone's connected to port 20 all the time and it's fine, like let's say it's a file transfer protocol port, and knows like, oh, this isn't dangerous, cool, whatever. But if we're trying to connect, let's say I think port 13 is blocked off the top of my head, but let's assume it is for what we're talking about. We go, hey, why is this always trying to connect to port 13? No, block it, block it, block it, block it, block it. And you just won't let it connect. So, Unified Threat Management Firewall, UTM. These are now what's cloud-based, essentially, software as a service, that kind of thing. A UTM device typically combines in a loosened, coupled way the function of a stateful inspection firewall, so it takes this guy. Intrusion prevention system. So that's more of a security software thing, and also security as a service, which is also SaaS, right? Software as a service. And antivirus. So it does 3 jobs. It does the job of this guy. It provides intrusion protection, prevention, and antivirus. Pretty neat, but that can be overbearing to configure too. Don't worry, I might have you do something with it. It may also include additional services and often cloud management. UTMs focus on simplicity and ease of use, but they can still get pretty dicey. So, we're doing good. Here's some more firewalls. We're on slide 20. It's only been 30 minutes. Yeah, I'll still cut it just to be fair. That's because I said I was going to do, right? So, different types of firewalls continued. Next generation firewall. Latest and greatest, right? Firewalls have evolved beyond simple packet filtering and stateful inspection. Most companies are deploying next generation firewalls to block modern threats such as advanced malware and application layer attacks. Like, I don't know, like DDoSing. You know what DDoSing is? Denial of service attacks. The next generation firewall must include intelligence-based access control with stateful inspections, integrated intrusion prevention system, so an IPS, application awareness control to see and block risky apps, upgrade path to include future information feeds, which it'll grab from is it SANS? I forget who publishes it stuff like every Tuesday. I think that's what we publish. I think it's SANS off the top of my head. If you're curious, again, that's just me. We can talk about it. Techniques to address evolving security threats. URF filter based on geolocation and reputation. So it takes a lot more into account. These new firewalls are pretty interesting. Different types of firewalls continues. I know, guys, there's more, right? There's one more after this, I believe. So threat-focused NGFW, next generation firewall, right? So these firewalls include all the capabilities, traditional firewalls, traditional next generation firewalls. Next generation, it's just a big word. And can also provide threat detection and remediation with threat-focused NGFW. You can know which assets are most at risk with complete context awareness, quickly react to attacks with intelligent security automation that sets policies and hardens your defenses automatically. Well, what's hardens? You ever gone and you connect or you use a machine that says, hey, you're only allowed to do this and this, and it'll kick you off like in 30 minutes for your own safety. If you've never seen it, that they're still around some government buildings that use them. Like you can go to court and they monitor what you're doing. What it means by hardening is it won't let it reach certain things. So you won't be able to get the file explorer. You won't be able to see this PC. You won't be able to see the C drive. Things like that. That's called hardening. That's a really soft example, but you can get to the point where. So I'll talk about the jail a little bit. We harden the machines in there manually. Well, what do you mean manually? There's a way you can go and you have to enable some certain Windows features inside Windows control panel itself. It's buried in Windows. And you can turn off settings. You can turn off the start menu. You can turn off Notepad. You can turn off the command prompt window. You can turn off so many things. But if you get to the point where you turn off too many things, you need to access something, you can't go back. So it gets to the point sometimes where you have to reimage and start over and remember what you did if you didn't write it down. But that's what hardening typically means. In terms of security, these firewalls can turn off ports, set new rules by themselves, and block things a lot more faster than what first generation firewalls could. So better detect evasive or suspicious activity with networking and endpoint event correlation, so it can compare and contrast things. That's a little bit terrifying for this stuff. Greatly decrease the time from detection to cleanup with retrospective security that continually monitors suspicious activity and behavior even after initial inspection. So I'll tell you this much, guys. During any cybersecurity event, be it a hack, an email that comes in, hey, click on me, you can become the next intern for Merced. It's a $500 sign-up bonus. We'll walk my dogs, whatever. This looks enticing. The first stage of any attack, doesn't matter if it's small, big, they hack, let's say, I don't know, the Pentagon, the Federal Reserve, something huge. First stage of any attack is reconnaissance. Well, what do I mean? They're not going to just go for it off the bat. I'm holding just tools. Don't worry. And they're always going to try to find out information about who and where and what they're going to attack. You can't just them going blind. And then when they send you an email saying, hey, click here to get a part-time job in Merced, or I'm saying Merced because it's college. So you probably have seen it. Click this link and fill out this application. It's $500 bonus, whatever. They're just trying to get information so they can use it. It's called social engineering. They can use it against you. And they can pretend to be you. So I'm going to segue out of this for a second. It's still security related. Don't worry. It's just tidbits of stuff I like to throw in, and hopefully you guys find it entertaining. And you remember the whole Las Vegas hack that happened recently with MGM and Hard Rock Cafe, and I forget who else, Caesars. Remember Caesars paid the bounty? I forget how much it was. It was a big amount of money. They were hit with ransomware. Well, so was MGM. But MGM was holding out the hope for a week that they could rely on a backup. But their backup was also locked, which they found out like 3 days ago. So you're probably wondering, well, how the hell did they get to MGM if they got to Caesars, right? The way they got to MGM was they went on LinkedIn, found the name of one of the network engineers or technicians that works for like a high up level technician, probably a very high level sysadmin, called in there to the MGM network help desk, pretended to be him, and requested their password be reset to something only they would know. That's how they gained access. Pretty weird, but pretty smart if you think about it, the way we went out doing it, and nobody questioned it. So that's going to raise a lot more questions for social engineering. Anyways, greatly, back to this, right? Greatly decreases the time from, we talked about that. Easy, I should say easy, not ease. Administration and reduce complexity with unified policies that protect across the entire attack continuum. What do you mean by policies? We'll get into that more. We'll do something with server. I'll have you guys make a policy, which is like a rule set. So it's like, what's a good rule? Like, don't yell fire in the theater, or where else do they let you do stuff? Like no walking dogs on the beach. You set all these rules that your computers have to abide to in user accounts. We'll do stuff like that. Don't worry. So you do know what I'm talking about. So firewalls continue. These are the last two. I promise. This is the last two. I know I don't mean to have a New York accent. I'm tired. It's Thursday. It's my Friday. I've had a busy day. Virtual firewall. A virtual firewall is typically deployed as a virtual appliance in a private cloud. VMware ESXi, Microsoft Hyper-V, KVM, or public cloud, Amazon Web Services, AWS, Microsoft Azure, Google Cloud Platform, or Oracle Cloud Infrastructure, OCI. To monitor and secure traffic across physical and virtual networks, a virtual firewall is often a component of software-defined networks, SDN. Cloud-native firewall. So these are just built up in the cloud. Cloud-native firewalls are modernizing the way to secure applications and workload infrastructure at scale with automated scaling features so they can bulk up and, go lean as fast as they need to. That's the thing about cloud in general. And I'm segueing out for a second because I'm talking about cloud. I know. But cloud has this scalability that, if I need more hard drive space, it can be allocated like that from another server just given to me. Versus my tower down here, I turn it off. I have to unplug the power, open up the side panel, pop in the M.2, screw it in, turn it back on, go into Windows, and do all that. It's a lot of steps versus the cloud go, hey, I need that yoink. That's what it means with scalability. It's faster. If you hear laughing in the background, I apologize. I guess people don't seem to understand the recording. With automated scaling features, cloud-native firewalls enable networking operations and security operation teams to run at agile speed so they can run a lot more quicker. Slide 23, guys. Here we go. So, security applications. You know what? I'll pause the video here, or stop the video here, and then I will see you in the second part of the first part for Unit 2. Till then, guys, take care.